All right, so let's get into this. Again, we're going to have, this is 1.3, and we're going to talk about functions and domain range restrictions. Domain and range restrictions. Nope, I don't like that line. There we go. Functions and domain and range restrictions. We talked a little bit about, we've talked about domain range for a couple assignments, but I just want to clarify this, right, about functions and how to write it all out. So a function is something that takes an input, which we call x, translate it through some function f of x, f of x, right? We want to translate it through some, like machine. You can think of a function like a machine, and then it gets an output, which is y. Now the input, we call that the domain, and the output, we call that the range. We talked about these last time. And we have some ways that we represent functions, right? We talked about functions. Functions are inputs and outputs, this connection, right? And some ways to represent functions, we have just points, right? Coordinate points. These are, x and y. You have an input and you have an output. You have your x and you have your y. Right? A series of points tells you what all the inputs are and what all the outputs are, what all the domain is, what all the range is. We have things like, if we have a series of points, we can make a table where we have a lot of inputs and outputs, right? Way you can represent a function. Inputs, outputs, right? All the x's, all the y's. We have graphs, right? Things like this or like this. Right, where the x is the inputs and the y is the outputs. And the way we tested these graphs was by doing something called the vertical line test, right? Vertical line test. To test if something was a function, right? We know to test this, we wanted to check our inputs and outputs, make sure they didn't repeat. For graphs, we kind of scan across, and as long as our function only touches one spot on these lines, our vertical line test touches only one spot every time, that's okay, that's a function. But if we touch in two spots, like here and here, that's not okay, not a function. So we have points, tables, graphs, ways we can represent these functions. If you have questions, let me know. The last way we represent functions is with, we're going to do this, go over here. With, no, stop it. The equations. Y equals f of x, right? And with the equations, we could tell if something was a function or not, right? If we had a y squared, or absolute value of y, or x equals, these three, x equals a number, were not a function. Every other equation, for the most part, pretty much every other equation, is going to be a function. Every other equation is pretty much going to be a function. Let me try rewriting this. Ways, whoopsies, to represent functions. Points, graphs, tables, equations. Ways that we can tell if something is a function or not. For the table and the points, remember our x value, our inputs cannot repeat. Cannot repeat. So we have these rules, right? Graphs, you can't have the double line. Equations, you can't have the y squared, and all those things. These were ways that four main ways we represent functions: graphs, tables, domain, equations, etc. Okay. We've seen all this before. What I want to talk about today is, can I move this up? If I move this up and you yell at me, let me know. I'm going to move this up a little bit. I'm going to go here. Yell at me if you need me to move it down. But we know that we have these two pieces, these two things we talked about. Functions are represented by a domain, which is our x-axis, and our range, which is the y-axis in the graph. And the domain is all, we're going to give a definition for domain range. Domain is all possible inputs allowed to a function. Allowed to a function. All the possible inputs that are allowed is our domain. All the possible inputs that are allowed. All the possible inputs that are allowed. And our range is all possible outputs. Outputs. Hold on. All possible outputs of a function. And I want to stress the word possible and allowed. Function. I have to get better at using this tablet. I want to stress these words here, all possible inputs that are allowed, all possible outputs that are allowed of a function. When we have certain graphs, we've seen this a few times before. In certain situations, functions are not allowed to receive certain inputs. Like when we give it a certain number, the function stops working. The function gives us an answer that doesn't make sense or that's impossible. And so how do we tell which inputs are allowed? Excuse me. How do we tell which inputs are allowed? How do we tell what we're allowed to have for outputs? How can we tell what our domain and range are? And so to do that, we're going to talk about domain restrictions. There are three, well, two really. Let's talk about, oh God, black. There are two main, no, let's just talk domain restrictions. How do we tell which inputs are allowed? How do we tell which inputs are allowed? How do we tell what restrictions are? How do we tell what the domain of a function is? So normal functions have no restrictions. Things like lines, things like quadratic equations, even absolute value equations have no restrictions. Nothing is not allowed. A quadratic function, you can plug in any number. Absolute value, you can plug in any number. A line, you can plug in any number. Most functions, any polynomial equation, you can plug in any number. So all of these functions, the domain is what we call all real numbers, which in this case we said was that big double-barred R. Right? Normal functions are not restricted. We want every possible input, right? We want to be able to do all the inputs. But there are a few functions, a few ways that we limit the domain. And there's two main ways. Two restrictions. Two, what do you call them? Ways to limit the domain. Our first way is when you have a variable in the denominator. For example, if f of x equals 1 over x. This is going to cause us to have a restriction. It's going to limit what is possible, what is allowed to be plugged into the function. When you have a variable on the denominator of an equation, there are certain numbers that the denominator is not allowed to be. Certain numbers we're not allowed to divide by, right? And that number we are not allowed to divide by 0. The bottom cannot be 0. And that is going to be a restriction. The bottom of this fraction we cannot divide by 0. So that limits, right? It takes away specific numbers that we're not allowed to use in our domain. So we limit our domain when there's a variable in the denominator. It makes it so we're not allowed to plug in those numbers. So for this function, because the bottom can't be 0, our domain is going to be all real numbers. Everything else is fine, except x equals 0. So we have our restriction. Everything else is fine, but the one thing I am not allowed to plug into this equation is a 0. Normal functions, like I said, we want to have every possible input. Normal functions have all real numbers as their domain. But when we limit the equation, when we have a fraction, a variable on the bottom, we limit our options. Only a variable, only an x on the denominator is what causes the problem. I can have any number on the bottom I want. It doesn't matter. But when I have a variable on the bottom, when I have a variable in the denominator, that's where things get dicey. So let me give you another example. Come on. What if I had f of x equals 5 over x plus 2? What is my restriction for this? So I know that the bottom cannot be equal to 0. This little symbol here with the equals with the line, that means can't be equal to, right? Not allowed. So I know that x plus 2 cannot be 0. Right? Look at the bottom. X plus 2 cannot be equal to 0. So I can solve this. This is like an equation here. It's a cannot equal equation, but it's like an equation. If I solve this, minus 2 minus 2, I'm going to get a domain restriction that says x cannot be equal to negative 2. And this is my domain. We would say all real numbers, x not equal to negative 2. So you can describe it in words, all real numbers except 0, or you can describe it using the mathematical symbol, all real numbers except for negative 2. One more example. What is the domain of this equation here? So x minus 3 over x squared minus 9. What is my domain? So we start assuming that all real numbers is my domain. I start assuming that it's all real numbers. But then I look and I see I have some restrictions, right? I have a variable on the denominator. So I'm going to have some restrictions. This domain, there's certain numbers that are going to be not allowed. How do I find those numbers? So I make the bottom equal to 0. What numbers would make the bottom 0? And since it's a squared, I should probably factor the denominator. If I plug in 0, 0 into x, 0 squared minus 9 is going to be negative 9. That number is fine. I need to figure out what numbers would make the bottom 0. Like here on the bottom, when I plugged in, if I took this negative 2, right? If I took the negative 2 and I plugged in negative 2 here, negative 2 minus 2 made the bottom 0. So that's why negative 2 was not allowed, because it made the bottom into a 0. For us here, with this x squared minus 9, how do I know? Here, you see all you did was take this number, this is called a factor, and you did the opposite, right? It was positive 2 here, and so your answer was negative 2. Kind of the opposite. So this x squared minus 9, I need to factor this apart. I can do do this parenthesis thing, and I see this is a perfect difference of squares, x squared minus 9. Hopefully you all know. Right? Do we all remember how to factor? X squared minus 9 factors into x plus 3 and x minus 3. We want to take this x squared minus 9 and break it into the two parentheses that we see here. And so this function now is x minus 3 over x minus 3, or x plus 3 times x minus 3 on the bottom. So now I can if you see this, we've done this before, we've simplified these equations. You see this x minus 3 on the top, this x minus 3 on the bottom? I can simplify and cancel those out and get 1 over x plus 3. So I can simplify this equation. We've done that before. So now what is going to be my restriction for this one? What is my domain here? Domain is going to be all real numbers except, which ones? Except which number? Except, yeah, negative 3, right? X cannot be equal to negative 3. Except x cannot be equal to negative 3 from this one here. But what about this other one? This x minus 3. I know I canceled it. I know that I canceled it. So, like, isn't it gone? Well, equations have memories. Equations remember what they originally were. This equation, this 1 over x minus x plus 3, this equation here that we made, it's got a memory of its original form. This is not even my final form. This is original form of this equation. Right? It has to remember where it came from. It has to remember what it was. And so we have to remember that it had this piece on the bottom too. Yeah, it simplifies, it goes away, but we have to remember it. Like a memorial. Remember x minus 3. And so this means that x also is not allowed to be positive 3. Because we have to remember that restriction from before. Or x cannot equal 3. I should say not or, I should say and. And. So we have to remember what the equation was before. It doesn't disappear, right? This x minus 3, even though it canceled, it doesn't disappear. It has to remember we had our original equation. We are finding the domain of this original equation. And the original equation had these two things on the bottom, and every one of these things creates a restriction. So here, every factor is a restriction. Every factor is a restriction. So every parenthesis we have, even if it's canceled, it still has to be remembered. We still have to remember it. Okay. So that's one way to restrict domains. There were two. Variables on the bottom is one. The second thing that restricts domains is when you have square root equations. Square roots will also restrict your domain. Okay? Square roots will restrict your domain. And the restriction is that the reason why this restricts it is that under the square root, the part under the square root, right, you're only allowed to take a square root of a positive number, right? Must be positive. You're only allowed to take a square root of a positive number. Those are the only numbers that are allowed. So the restriction is whatever makes this inside number negative is not allowed. So we would say that the inside part has to be greater than or equal to 0. The inside part of the square root has to be bigger than 0. That's what it means. Must be positive means you have to be bigger than 0. So this is our second type of restriction. If you have an equation with a square root, the inside part of the square root has to be bigger than 0. Say we have a function, f(x) equals square root of 2x plus 6, let's say. Square root of 2x plus 6. What is my domain of this equation here? Okay. To find the domain, take the inside and make it greater than or equal to 0. So I'm just going to take whatever is inside my square root, and I'm going to say my domain is 2x plus 6 must be bigger than or equal to 0. And then you want to simplify. That's your domain, right? Your domain is the inside part has to be bigger than 0, bigger than or equal to 0. And I want to simplify this. I want to get the x by itself. So minus 6 on both sides. I'm going to get 2x greater than or equal to negative 6. Divide by 2, divide by 2. I'm going to get x greater than or equal to negative 3. And that would be my domain. X greater than or equal to negative 3. Okay. Questions? So these are our two ways to restrict our domain. We have variables on the bottom, and numbers inside of a square root, equations inside of a square root. Variables on the bottom or variables in a square root, those are our two ways to restrict our domain. Otherwise, your domain is all real numbers. The domain is all the real numbers. And that's easy. Now, what about the range? Ooh, what about ranges? Well, what about well, let's say, what about for crazy equations? For crazy equations, to find the domain and range, you want a graph. You want to graph. The best way to find the range is to look at the graph. Look at the graph. There's really no trick for finding range. To find the range, the only real way, the best way, I mean, you can plug in a million numbers, but the best way is just really to look at the graph. There's a few rules, but there's like, I don't know, too many complications. So for example, if you have an equation like y equals x plus 2 squared minus 3. What's the domain and range? So first question, the domain. Do we have any restrictions on this domain? Does it have a variable in the denominator of a fraction? Does this equation have a fraction denominator variable? No, it does not. Is this equation in a square root? Is this equation inside a square root? No, it's squared. That's different. No square root. No fraction. That means my domain is automatically all real numbers. Right? Those are my only two restrictions. If I have one of those situations, I got to figure it out. If I don't, it's all real numbers automatically. So that's my domain. What about my range? Well, range, again, a little trickier, right? I have to look at a graph. So let's graph this equation. This equation's graph is going to look something like this. And the bottom here is going to be at negative 3. So my range, you see it's going to be negative 3 here. It's all the numbers above negative 3, right? And we talked about how to write that, right? We would say y is greater than or equal to negative 3, or we can say negative 3 comma infinity, right? We talked about the parenthesis version or the inequalities. Talked about how you can use inequalities. Inequalities or interval notation. Let me write this a little bit better. Inequality or interval. And you'll see, like, different books, different people have different, one book may use one way, one person may use another way. They're both fine. Which you prefer? I don't care. I will understand them all. But for crazy equations, you want to do some graphing. Okay. What else? There's another example. For example, oh, not y. There's a function, f of x equals, let's say, negative 2x, negative 2 to the power of x plus 1. Negative 2 to the power of x plus 1. What is that graph? What is that domain? And what is that range? Domain, range. This is an exponential equation. Exponential equation. So, let me ask you, for my domain, yeah, all real numbers. It's not a fraction. I have no restrictions there. I got no square roots, so we're all real numbers. No problem. For the range, I need a graph. So let's see what this graph looks like. Someone want to plug this into Desmos. Graphing calculator. This is an inequality. It's exponential. So I'm going to have at positive 1, here's my y-intercept, at positive 1, my y vertical shift. I'm going to have some dotted lines there. And it's going to go something like this. Let me try doing this a little bit better. It's going to go something like straight line and then kind of curve down like that. Something like that. And what was this dotted line called? We had a name for this dotted line. Our favorite word. Asymptote, yes. A barrier from which the line cannot get to. So what is my range then going to be? Well, we see this asymptote is here. We see I have this restriction, right? We're going to go everything from 1 and down, right? So the range is going to be everything from 1 down. So I want to say y is everything less than or equal to 1? Is that what I want? Well, yeah, no, we don't reach the value of 1. Right? We don't actually get to 1. So I just need to be less than 1. Not less than or equal to 1. Just less than 1. And the same thing happens with my brackets, right? I can say, beginning bracket, my lowest number is negative infinity. So I got to start with negative infinity. And I go up to 1, but I put a parenthesis there, right? Parenthesis means I don't touch. I don't touch 1. We don't actually reach the number. We get to a barrier that's close to the number. Starting at negative infinity, up to 1. Ooh, I'm at the bottom. Good thing we're almost done. Last example. What if I have the function f of x equals 1 over x plus 3 x minus 1? What's my domain? What's my range? Well, domain, again, we have to ask our question. Do we have a situation where we are restricted? Do we have a fraction with a variable on the bottom? Yes, we do. We have our x plus 3 and x minus 1 on the bottom here. Do we have a square root? No, so we don't need to worry about that. But we do have a restriction. The numbers that x cannot be equal to, it's all real numbers except for which two numbers? X plus 3, x minus 1. How are these going to change? What restrictions are we going to make? Remember, with factors, the number changes sign. So if I have x plus 3, the restriction that's going to make it 0 is negative 3. Except x equals negative 3 and positive 1. Positive 1 is going to make it 0. So a little note here to find, hold on, let me do it somewhere else. A little note here to find restrictions. Oh goodness, restrictions flip the sign. Flip the sign. To find restrictions, flip the sign. So I had x plus 3, right? Now you have negative 3. X minus 1, now you have positive 1. So the restrictions, you flip the sign. For the range, well, let's take a look at this graph. This graph is very interesting. At 3, negative 3, and positive 1, at negative 3, 1 to negative 3, here, and at 1 here, we are going to have our domain restrictions. And the graph is going to look something like, it's going to look like this, like this, whoops, and like this. So that's going to be our graph, what it looks like. We have a kind of, right, oh God, we have a kind of curling up on the bottom here, tracing these asymptotes, these vertical asymptotes. Here, let me write that down. We have these vertical asymptotes here. Oh God, what happened? Vertical asymptotes. Asymptotes here and here, right? And those vertical asymptotes represent our domain restrictions, right? At negative 3 and at positive 1. Those are the lines, right? You see, we skip over those numbers. That's our domain restriction. What about our range restriction? What number does it look like we skip over in the graph? Well, we have all the numbers down here, all the numbers up here, but it looks like there's a spot where the graph kind of like doesn't cross. Where is that? Yeah. Ricardo got a 0, right? It looks like the graph, and this is actually another horizontal asymptote. And there's no way, I mean, unless you know the patterns, there's no way to know that that's going to be a restriction, unless you look at the graph. It's probably the easiest way is just to look at this graph. So our range also has a restriction. I can say all real numbers, except I want y to be 0. Or I guess I could say not equal to 0. Y is not allowed to be 0. I guess I should have said that for the x too. Not allowed to be equal to 3 and negative 3. So our range, really the best way to find the range is looking at the graph. And the domain, you only need to worry about 2 restrictions: fractions or square roots. Okay? All right, any questions? I think people want me to scroll back up too. Domain range. Look at these graphs. Domain, just think of those 2 restrictions and that's it. Okay. Let me see if I can zoom out a little. Oh God, look at all the things we did today. Oh wow, I should have gone. I can start way at the top. Yeah, I should start these notes way at the top. Give me a whole lot more room. Anyway, things to know. So we talked about, what did we talk about today? We talked about domain restrictions, right? We talked about function representation, how to represent functions, graphs and tables and equations and domain and range. And we talked about the restrictions. Normal functions have all real numbers. For the domain, typically we want everything. But there's two main things, right? Fractions on the bottom, or square roots, that give our domain some restrictions, right? Square roots, we have to have greater than or equal to 0, and then you solve that equation. For other weird equations, to find the range, the domain and range, you want to graph them. You want to graph them, and that's really the only way, or the best way, to find the range of an equation. Just look at it. Look at it and see. Desmos will be your very best friend for these equations here. Okay. So let me tell you the homework assignment. Let me go do it up here. Homework assignment. It's going to be the same section 1.2, page 26. I want you to do numbers 53 through 66, all. And I want you to, for 53 to 62, find the domain only. For 62 domain only. For 63 to 66, find the domain and the range. So 53 to 62, you only need to find the domain. For 63 to 66, find the domain and the range. Okay? Some very interesting equations we've got there. So hopefully that'll, give you some things to work at. That's it for us, folks. I'm going to stop my recording, and I will see you next time.